Polymers. You can find them in your clothing, DNA, materials you can get from the trees around us, resins, and more. They can be considered as essential items that we use on a day-to-day basis.
Take this analogy. Our chemistry class, along with our chemistry teacher, Miss Mariana, are about to embark on a train to get to Bandung. In said train, there are so many cars linked together. The cars represent the monomers of a polymer, while the linkages are the bonds made. Altogether, this forms a chain of monomers and thus a polymer.
Hi, I'm Bridget and this is my friend Karina, and in this video we are going to be covering part 3 of the polymers chapter in A-levels. Today we will be talking about polyamides like nylon, Kevlar, and protein, as well as the first commercially used synthetic plastic, Bakelite. Keep watching to learn more about them. First things first, let's talk about some definitions. Polymers are molecules whose structure is composed of multiple repeating units, the monomers. While polyamides are polymers where the repeating units are kept together by amide bonds and are formed by reacting dicarboxylic acids and diamides together.
With those definitions in mind, let's begin with our first polyamide, nylon. Nylon can be made from a variety of monomers, but all nylons are made in reactions between the amine group and a carboxylic acid or acyl chloride group. There are various different types of nylon depending on the nature of the carbon chains. Today, I will be talking about two different types of nylon. The first type is nylon 6,6. Its monomers are 1,6-diaminohexane and hexane dioic acid. The numbers used in nylon 6,6 refers to the number of carbon atoms in each of their monomers, with each monomer containing 6 carbon atoms. When these two monomers polymerize, the amine and acid groups combine and water is released. An amide link is formed, and this process is known as condensation polymerization. Another example of nylon is nylon 6. This is the only example of a nylon polymer that is not formed by condensation polymerization because no small molecule is given off. Nylon 6 is made from a single monomer called caprolactam, which is basically 6-aminohexanoic acid. It is a cyclic amide. When this molecule polymerizes, the ring opens at the amide group, and the molecules join up to form a continuous chain which joins together to make nylon 6. Nylon is a polyamide used in textiles. It is a very useful fiber in the clothing industry due to its low density, strength, and elasticity. These properties also make it ideal for climbing ropes.
Next up, we have Kevlar. Kevlar is a polyamide containing benzene rings. It's made out of benzene 1,4-dicarboxylic acid and 1,4-diaminobenzene. To form Kevlar, a copolymerization reaction occurs between benzene 1,4-dicarboxylic acid and 1,4-diaminobenzene. If you line these up and remove water between the COOH and NH2 groups in the same way as we did with nylon 6,6, you get the structure of Kevlar. Now, Kevlar is often used as bulletproof resistant body armor, ropes or fabric, bicycle tires, and racing sails. Properties that could be found in Kevlar are heat resistance, strength, the resistance to abrasion, and flexibility. Now I see why Batman decided to use this material for a suit. The reason why it's so strong is because the long linear polymer chains can line up next to each other in a regular pattern, and this intermolecular hydrogen bonds between the carbonyl groups and NH centers, and as we know, hydrogen bonds are the strongest intermolecular force.
2 down, one last polyamide to cover. Our last polyamide of the day is protein. There are a lot of proteins, each with a particular biological function. Some examples of proteins you might know are enzymes, hemoglobin, and certain hormones such as insulin. But what exactly are proteins? A protein is a naturally occurring polyamide. Again, polyamides are polymers with an amide link, which can also be called a peptide link. This is the structure of a typical polyamide. In between the amide groups, you can see an R. This can be anything. However, in proteins, the R represents a single carbon atom that is connected to a hydrogen and an alkyl group. In your body, these proteins are made from monomers called amino acids. Amino acid molecules have two different functional groups, the amine group and the carboxylic acid group. Proteins are formed through condensation polymerization, which joins together thousands of amino acid molecules. And just like any other condensation polymerization process, water molecules are removed.
Now let's talk about Bakelite. Bakelite is a polymer formed by polymerization of monomers, phenol, and formaldehyde. Formation of Bakelite follows electrophilic substitution reaction of phenol with formaldehyde followed by condensation. Fun fact, these are one of the oldest polymers that were synthesized by man. Since this element has a low electrical conductivity and a high heat resistance, it can be used in manufacturing electrical switches and machine parts of electrical systems. Phenolic resins are also extensively used as adhesives and binding agents. They are further used for protective purposes as well as in the coating industry. Furthermore, Bakelite has been used for making the handles of a variety of utensils. It is one of the most common and important polymers that are used to make different parts of many objects.
Let's recap. We've learned about the definitions of polymer and polyamide, types of polyamides, how they're made, and their uses. We really hope you learned something new from our video.
Thank you for watching, and we'll see you next time. Bye bye!